the session of classes and functions. In this session we will be writing a class, and we will be writing functions. Two types of functions will be learning in this session: pure functions and modifier function. And we'll also see some styles of programming called as functional programming style. We will also learn about prototyping versus planning, and a concept called as invariant. So let's begin. So let's start with pure functions. Now, in the last class we have learned how to write classes, what are objects we have learned, right? Now, when I'm creating a function, I can pass objects to the function as argument, and I can return an object from a function. Now, inside the function, you have the choice of modifying the object which you have received to your function, or you can keep it as it is without modifying. You can just use the values, but you're not going to modify. So in such cases where a function will modify an object, it is called as a pure function. So pure function is a function that a pure function is a function that does not modify any of the objects it receives as arguments. You're not going to modify any of the objects here which you are receiving as argument. And it's always advantageous to have pure functions, because suppose you modify the objects, then you should ensure that this modified object does not have any other effect on the rest of the programs. Okay, so when you are modifying an object, then you should keep track of that modification and ensure it does not affect your program elsewhere. But pure functions, just to revise, they are functions where you do not modify the objects which you are received as an argument. So this function is an example of a pure function. So let's assume that I have already created a class. Okay, let's say I have created a class called as time already. Okay, and somewhere else in the program I'm writing this function, right? So let's say the name of the function is add_time. And T1 and T2, suppose let's say these are the objects of the class time. Okay, so I am passing T1, T2. What is T1, T2? They are objects. Let's say T1, T2 are objects of class time. So what we have done here is we are passing two objects to this function add_time. Okay, now inside the function also I am creating an object. Inside also sum is also object of class time. Now I am doing this inside. Okay, inside the function I am also creating my own object. So let's say the intention of this program is, let's say in time class we have three variables. Okay, let's say it has three variables: hours, minutes and seconds. Okay, so T1, T2 will have again three variables under it: T1.hour, T1.minute, T1.second. So that's how you access, right? How do you access the variables of an object? Through a dot operator. So similarly sum also will have sum.hour, sum.minute, sum.second. So we are just going to add up the time T1 plus T2 and give it into sum. So that's what we are going to do. We are going to add T1 and T2 and give it to sum. So you have to add it individually, right? So the hour is added individually and given it to sum.hour. T1.minute and T2.minute is added and given to sum.minute. T1.second and T2.second are added and given to sum.second. And basically this function is returning sum, which is again an object. As you can see here, we just use the values of T1 and T2 object. We did not modify it, right? The calculations we kept in a different object and we returned that. So that's why this is an example of a pure function. So let's say how you can use it in your main program. So in your program I can do something like this. Let's say I have let's say this is my main program where I have created again an object called as start, which belongs to the time class, and suppose I'm saying these are the values: start.hour is 9, start.minute is 45, start.second is 0. Similarly, let's say I'm creating one more object of the class time, and I'm saying duration.hour is 1, duration.minute is 35, duration.second is 0. Now let's say I'm calling the function here, right? I'm calling this add_time function here, to which I'm passing two arguments. Which are the arguments? They have to be objects. So the first object is start, the second object is duration. And the value, what value is returned from this function, that would be stored in done. So basically what happens here, what happens here, start is nothing but, the value of start is nothing but passed to T1. The value of duration is passed to T2, and individually the hour, minute and second will be calculated. So what actually will be printed? You are printing the sum, right? Sum is calculated and it is returned to done. Right? We have discussed about function calling, how we can write functions in the previous sessions, a link to which I'll give it in the description box. So what is basically printed? 9 plus 1 is a hour, so 10 hours. 45 plus 35 is the minute, 80 minutes. 0 plus 0 is the seconds. So the final calculation what I'm getting is 10 hours, 80 minutes, 00 seconds. Now as you can see here, this function is not really giving you a correct answer, because if you have minutes greater than 60, then you should 20 minutes more, so that means you should add 1 hour to it. So actual answer which we expect here is 11 hours 20 minutes 00 seconds. That is what you need to give. So that means this function is not handling that, right? So we need to alter this program. When the minute, addition of minute is greater than 60, then you have to increase the hour. If the addition of seconds is greater than 60, you have to increase the minute. So we have to add that new. So this is the improvised version. Okay, so this is an older version of the function, similar to what I showed here. It is the same thing here. This is an older version of the add underscore time function, which we have now modified here. So how we have modified is, the modification is shown here using if statements. See, we are adding hours, we are adding minutes, we are adding seconds and putting it in sum dot hour, sum dot minute, sum dot seconds. Now what we are doing is, now if sum dot second is greater than equal to 60, if the addition is greater than equal to 60, we will minus 60 from that, right? Sum dot second minus equal to 60, and we will add 1 to the minute. Sum dot minute plus equal to 1 means sum dot minute is equal to sum dot minute plus 1. Similarly, we will also do the same thing for minute. If the minute is greater than equal to 60, minus 60 from the minute and add 1 to the hour. So finally we are returning sum. Okay, so finally we are returning sum. So this is an improvised version, but this is still a pure function only. We did not modify T1 and T2. We are modifying sum. We did not modify the object that was passed as an argument. We created our own object in our function and we modified that. Okay, so that's why this is an example of pure function. Now coming to the next one, modifier function. See, modifier function is the reverse, opposite of pure function. Here we are going to modify the objects which we receive as arguments. So modifier is a function that changes one or more of the objects it receives as arguments, and most modifiers are fruitless. That means it's going to give some kind of problem, because we are it's not always. If you keep track of it, then it's not a problem. See, when you are modifying the objects in your function, then you should ensure that in the rest of the program, this modified object will not affect the rest of the program. Okay, so you have to ensure that. But in some cases, this may be acceptable. It may be needed. You may have a requirement that you modify the object. It can be there, but ensure that this mutable object or modified object does not affect your rest of the program. You keep track of that. Okay, so what are modifiers? Modifiers are functions that change one or more objects that it receives as an arguments. Okay, so the previous example only we are modifying, right? Here also we are doing the same thing. Let's say I give the name of my function as increment now. So what we are now doing is, I'm just a little bit modification. We are passing time and seconds as arguments, which are of course the objects. Okay, so now what we are going to do here is, suppose I have something, and I want to change the time. I want to change the object. So basically, time here is the object. Okay, time here is the object, and second is not an object. So here what I'm going to do is, suppose only seconds are given, right? Suppose 100 seconds are given as a value, and time is the object of the class. So what we are doing is time dot second plus equal to second. So what is happening here is, I'm modifying here the object time. Let's say here the object time is having just two variables, seconds and minutes. So basically what I've done is, this part of the function, right? This part of the function we are doing it here, right? We are taking care of that here in this modifier. Okay, so how we are doing it? If we are just going to add the seconds and keep it in the object variable time dot second, and if time dot second is greater than equal to 60, then we are going to minus 60 from that and increase the time dot minute. Similarly, if time dot minute is greater than or equal to 60, I'm going to decrement 60 and I'm going to increment r. Okay, so the functionality remains the same. We have done the same functionality like back before, but we have modified the object. Here the object is time. Okay, we have just passed one object called as time, which we are modifying. Okay, now this can also have a problem, right? If the parameter seconds is much greater than 60, much greater, so in this case what we can do is, it's not enough to just carry once, we have to keep doing it, right? For example, here it's not just enough you do it once. For example, I'll take an example of seconds. Okay, let's say I have seconds is equal to let's say 1200. Okay, so what happens to time dot seconds then? Time dot second would be, I'm doing plus equal to second, which would be seconds I'm doing. So basically what would be the value? That means time dot second is going to contain what would be the value. Suppose initially time dot second is 0. So what would be the value then? 0 plus let's say 1200 would be passed to time dot second. Okay, so what I have done here is I've just taken an example. Initially, let's say time dot second is 0. Okay, and seconds is 1200. Now what does this statement do? This statement, what it will do is it will add 0 plus 1200. So the value of time dot second is 1200. Now is this greater than equal to 60? Yes. So in that case what's happening is it will minus 60. So time dot second, in that I will do minus 60. So what would be the value? 1200 minus 60. So you are going to get 1140, and time dot minute would be incremented by 1, right? It would be incremented by 1. So it will become whatever the previous value was, for that we are incrementing. But still it does not serve the purpose. It is still a wrong value, right? So that's what this problem is. The problem with this function is, suppose the seconds is much greater, right? Then the minute will increase increase by 1. Whereas it is supposed to, this is supposed to loop. You're supposed to loop this until time dot second, becomes equal to 60. So that is what is written here. If the parameter seconds is much greater than 60, in that case it's not enough to carry once. So we have to keep doing this until time dot second is less than minute. So in that case you can use a while loop. Okay, and you also have let's say I want to write a pure function of increment that creates and returns a new time object rather than modifying the parameter. So we will look into this assert statements in the next session. Okay, so just a quick revision of mod is a modifier is a function that does not change, that it's a function that changes the objects which are received as arguments. It may not change all, it can change one or all the objects that it receives as an argument. And this is an example of a modifier. And the problem with this modifier function here is, if the minute is much, it is also there here, right? In the previous one also, it's not just it's there here, it's also there here. If the minute or second is much greater, then this kind of coding will not handle it. It will give you a wrong answer. So we will see how to handle this in the next session, where we will see a complete program. Okay, because the discussion will take time, we will see it in the next session. Now coming to the next one, what is a functional programming style? Now this is a style of programming in which majority of the functions are pure. Okay, so functional programming style is a style of programming where most of the functions are pure. So anything that can be done with modifiers can also be done with pure functions, right? We saw that the same, the functionality remained the same. I could implement a pure function, I could also implement a modifier function. So any functionality, it's your choice. You can implement using pure functions or modifier functions. Now, the advantage of pure functions are they are faster to develop and they're less error prone, right, as compared to the modifiers, because you are not changing the objects, so you are ensured that it will not have some kind of detrimental effect on the other parts of the program. But when you see modifiers, when we are working, we will see that it's very convenient, right? We are modifying the object then itself and we are passing it back. So we feel it is convenient, but it can be less efficient. You have to be ensured that it doesn't affect your program. So it's recommended that we write pure functions, as it is more reasonable and easier to ensure there are less errors, right? So this kind of programming, where majority of our functions are pure functions, is called as functional programming style. So it's an approach, it's a programming approach where most of our functions are pure. Okay, now in the next session also we'll be learning a concept called as invariant. I'll just give you an introduction to this. Invariant is a condition that should always be true during the execution of a program. So in the next session when I'll be doing a complete program with respect to this time, where we'll be using pure functions, we will just quickly revise modifier functions, and we will see a concept called as invariant. So what is invariant? It is a condition which always should be true during the execution of a program. So where we will see how we can handle this problem. Okay, we will see through a program in Jupyter Notebook how we can handle this program. If suppose a time is much greater than 60. See, one way of handling is you can do it using a while loop, but without using a while loop, where I will say as long as time is less than is not equal to 60, you keep repeating this. Right, this program can be easily handled using a while loop. As long as the time dot minute is not less than or equal to 60, you keep repeating this. Or another way of doing is invariant concept, which we will learn in the next session. Now coming to the last part of this today's session, what's the difference between prototyping and patch and planned development? See, what we learned now is prototyping and patch concept only, because what I did was I was taking a function, I was writing only the function. I was doing modification only on a function. I did not look into the whole algorithm, right? So that is called as prototyping and patch. So prototyping and patch is a development plan that involves writing a rough draft of a program. That's what we did, right? I wrote a pure function, I did modification of that and made an improvised version. I wrote a modifier function and we saw what was the problem. So we are making a rough draft of a function. So that concept we call as prototyping. And then I am testing it. I am correcting those errors. So I am doing patch wise, right? I'm making a rough draft, I'm testing it, I'm correcting it. So I'm doing a prototype, I'm making patches over it where I'm correcting the errors as I find it. So each function we are writing a prototype, we perform the basic calculation, we tested it, and we are patching the errors along the way. So prototype patch involves this, right? This approach can be effective when we don't have a deep understanding of the problem, when we don't know exactly the complete problem. When we are doing patch wise work, when we are doing modularized work, then this method is very effective. But this can have some kind of problems also, right? Because we are not really knowing about the entire development plan. It can lead to some kind of complications, some kind of unreliability, and it's hard to know where we might get problem with this function when we are using it in our complete setup. Okay, so another kind of approach is planned development, where we will have a high level insight into the problem and we have more planning and than incremental development. See, the first one, this we call it as an incremental development, where we'll do small parts and we go on increasing. So prototype and patch, we can call it as an incremental development or a prototype development. But planned development is, we can say it as a higher level of insight into the problem, and therefore makes the program much easier. As we have an overall overview of what is the complete problem, we can have better solutions and better programming and less error prone. So that's it for today's session. So to quickly revise, in today's session we saw what are pure functions, we saw an example of what is a pure function, and we saw modifier functions, which is the advantages and disadvantages of both of them. We saw what is functional programming style and the difference between prototype and patch and planned development. So the next session we will be using this function and we will do a complete program, and we'll also use the concept of invariant programming style over there to learn how, instead of using while loop to take care of the problem here, we will be using invariant. Okay, so thank you so much. Any doubts, please let me know. Please put it in the comment box, and thank you so much, and please subscribe to the channel. Thank you so much.